You can tell when a machine doesn't understand the real world. It hesitates, freezes, or waits for instructions the moment anything unexpected happens. But the moment a machine can reason, see, and listen in the same loop, something subtle but important changes. It stops being confined to documents and screens. It becomes capable of understanding the world as it actually is, physical, unpredictable, full of friction and constraint. It's like trying to carry a tray of drinks through a crowded room. As humans, we constantly adjust, react, and rebalance. That's the kind of continuous adjustment digital systems have never had to do, until now. And once a system can maneuver and understand the world, it becomes possible for it to act within it. This is the shift toward embodied AI, and it marks the point where intelligence moves from simulation into reality. For years, AI lived in a purely digital space. Models processed text, images, and data, but they had no connection to the physical world. Robots existed, but they were rigid, pre-programmed machines that followed fixed instructions. The intelligence was on one side. The embodiment was on the other. They were separate systems. Embodied AI brings them together. It connects perception, reasoning, and action, so a machine can interpret its environment, make decisions, and adjust its behavior as conditions change. If you've ever watched an older robot arm in a factory pause because an object was slightly out of place, you've seen this gap. Or if something unexpected appears, a misplaced pallet, a blocked aisle, it stops and waits for help. An embodied system reacts differently. It sees the obstacle, understands what it means, reasons about alternatives, and replans its path. It doesn't freeze. It adapts. This pattern appears across every domain where the physical world introduces uncertainty. In agriculture, embodied systems can move through fields, identify crops, and adjust their actions based on soil conditions, weather, and growth patterns. In healthcare, assistive robots can navigate, recognize hazards, and support people with mobility challenges. And in manufacturing, robots can handle objects that vary in shape, weight, or position, tasks that used to require human dexterity. The common thread is the same. The system isn't following a script. It's responding to reality. What makes embodied AI possible now is the convergence of three capabilities. The first is multimodal perception, the ability to see, hear, and interpret the environment in a unified way. The second is agentic reasoning, the ability to plan, act, and adjust over time. And the third is physical control, the ability to move, grasp, balance, and manipulate objects with precision. When these capabilities combine, a machine can operate in environments that are dynamic, unstructured, and full of surprises. This is the direction intelligent systems are moving, from models that understand the world to agents that operate within it, to machines that can act with situational understanding, context, and adaptability. Not autonomous beings, but structured systems that extend what humans can do in physical spaces. And this shift leads to the final question in the sequence. If embodied AI is becoming real, how do we design these systems responsibly, not just for capability, but for safety, reliability, and the way they fit into human environments? That's the next frontier, the meeting point between engineered intelligence and human environments. If you enjoyed this video, consider subscribing for more future-facing content. And as always, thanks for watching.